class. Welcome to physics class. My name is Abraham. Today we are going to look at physical quantity. And when you say physical quantities in physics, these are the quantities that they are measurable. That is, quantities that their size and magnitude can be known. A typical example is mass. Mass. The mass of any substance can be, depending on what you want to measure, 2 kg, 5 kg, 10 kg, and so on. The 2, 5, or 10 kg are size or the magnitude of that substance. That is, the mass can be 2 kg, 5 kg, or 10 kg. So once you know the size now, the magnitude, that's so that mass is measurable. Another example is time. Time is measured in seconds. Then it can be 2 o'clock or 3 o'clock and so on, depending on what you want to measure. Another example is length. Length can be 2 meters, 3 meters, 4 meters, depending on what you want to measure. All these 2, 3, and 4 are the magnitude, which is ascribed to length. Other examples of physical quantities is velocity. Velocity is measured in meters per second. So you can have 2 meters per second, 3 meters per second. So depending on what you want to measure, what we are saying in essence is that this figure written give all the size or the magnitude of that physical quantity. Now, next is types of physical quantity. Types of physical quantity. Types of physical quantity. We have 2 types. 1, fundamental, or we call this one basic quantity. 2, derived quantity. Now, let's take them one after the other. The first one, fundamental quantity. Fundamental quantities are quantities from which all other physical quantities are being derived. I take it again. Fundamental quantities are those quantities from which all other physical quantities are being derived. That is, the fundamental quantities, they do not depend on other physical quantities. It is from them that other physical quantities are being generated. Example of fundamental quantity are mass, 2, length, 3, time. To mention but few, we have 3 on the board: mass, length, time. The next we are going to look at is fundamental unit. When you say fundamental unit, from the word fundamental quantity, fundamental unit are the unit of fundamental quantities. That is, each fundamental quantity must have a particular unit. And that is what we are going to look at now. Now, let's look at the various examples of fundamental quantities and their unit. Majorly, we have 7 fundamental quantities. I will mention them together with the unit and their symbol. The first one we are going to mention is mass. The unit for mass is kilogram, and the symbol is kg. At the same time, mass can also take gram. The symbol is G. The number 2 on the list is length. The unit for length is meter, while the symbol for this one is L. At the same time, it can be centimeter, while the symbol for that one is cm. Then number 3 on the list is time. The unit for time is second. While this one take S as the symbol. The number 4 on the list is temperature. The unit for temperature is Kelvin. You take K as the unit. While number 5 on the list is current. The unit for current is ampere. Ampere. The symbol for this one is A. Number 6 on the list is luminous intensity. The unit for luminous intensity is candela. And the symbol for this one is CD. And the last, which is number 7, is amount of substance. Amount of substance. The unit of this one is mole, and the symbol is MOL. Among these 7 fundamental quantities, we have the 3 major ones, which are 1. Mass. 2. Length. 3. Time. And the unit for this one is kilogram, while for this one is meter, while for this one is seconds. Now, the next thing from this 3 major fundamental quantity is SI unit. SI unit. That when you say SI unit in physics, it means systemic international unit or standard international unit. That is the unit that is generally accepted throughout the world. For instance now, the SI unit of mass is kilogram, while the SI unit of length is SI unit of time is second, dictate to all other fundamental quantities which have been written before. But since we have the 3 major fundamental quantities as have been written, we also have the three major fundamental units, which are kilogram, meter, seconds. These are the three major fundamental units, or it can be gram, centimeter, second, which will form the three major fundamental units: kilogram, meter, second, or gram, centimeter, second. Next is derived quantity. Derived quantity. Derived quantities are those quantities that are being derived from combination of two or more fundamental quantities. That is, when you combine two or more fundamental quantities together, what is going to result to is derived quantities. A typical examples of derived quantity is speed. Speed. Speed is distance. As I said, a typical example of derived quantity is speed. Speed is distance over time taken. Now, as I said, under the definition of derived quantity, you can now say that speed is formed from distance and time taken. Distance also is a fundamental, but its own fundamental is under length, while time is also fundamental. So speed is formed from two fundamental quantities, which are distance and time. Now, the next is derived unit. As we have fundamental unit, so also we have derived unit. And when you say derived unit, these are the units of derived quantities. That is the unit of derived quantities. From the example on the board now, we want to write the unit of speed now. It means for speed, the unit will be, distance is meter, that will be meter. Time is second over second, then it will now give us meter per second. So that's where we have meter per second for speed. This one also is derived unit now. It formed from the combination of two fundamental units. Now, let's look at other examples of derived quantities. There are derivation of formula, derived units, and the number of quantity that each derived quantity contains. Now, let's do it in a tabular form. The fourth column, derived quantity, followed by formula or derivation, then unit, the number of quantity that it contains. The first one we are going to mention, one, is area. Area, in mathematics, the area of a rectangle is length multiplied by breadth. Length multiplied by breadth. This one will be L multiplied by B. And the unit of length already is known, which is meter. Breadth is another fundamental quantity. It means area is formed from combination of length and breadth. But breadth is also under length. That is why the unit of area will be meter square. And don't forget, as I told you the other time, under fundamental quantity, that the unit of length can also be centimeter. Then it can also be written as or centimeter square. Now the number of quantities that area contain now, let's count it from here. That will be 1, 2. It will be 2 quantities. 2 quantities. The next example is volume. Volume. As example 2. Volume of a cupboard in mathematics is length multiplied by breadth multiplied by height. And all this one, the unit have been known from fundamental level, which is meter for length. It will be the same meter for breadth. Height also is another fundamental quantity. So the unit also is being related to length. So this one now will be meter cube. And counting the number of quantity that volume will contain, that will be 1, 2, 3, making 3 quantities. Or as I said, you can take it as centimeter cube. Now, the next example is number 3, which is density. Density. Density in physics is, the formula is mass over volume. Mass over volume. Note this, already mass is, the unit of mass from fundamental unit is kilogram. The volume is already known. It means the unit of density will be kilogram per meter cube, or it can be gram per centimeter cube. And the number of quantities that this one can contain, let's analyze further. That will be mass over length times breadth times height. If you count the number of quantities now, 1, 2, 3, 4, that's making 4 quantities that can be formed from density. Next example, which will be number 4. Which is number 4. Let's take speed as the next example. Speed. Speed, as I said the other time, is distance over time taken. And from this one now, distance is fundamental, time is fundamental. So the unit of speed will be meter per second. Now, from this, to count the number of quantities now, that's 1, 2. So the number of quantity for speed now is 2 quantities. Now, the next one is surface tension. Surface tension. The formula for surface tension is force over length. Force over length. Now, from here now, you can now see that force is derived, length is fundamental. It means to note the unit of surface tension, we can now say that 1. This one is Newton, length is meter. So the first unit of surface tension will be Newton per meter. Take note. To express further, so that we can know the number of quantity that surface tension contains, Force from physics is, the formula is ma. That is, this a is linear acceleration, then over length. Now, from this point again, we can see out another unit. Note, mass is kilogram. Acceleration in physics is meter per second square. This is another meter. So we can now say over meter. Then meter we cancel meter. So we can now have kilogram per second square. This one will be another unit of surface tension apart from Newton per meter. So we can see a kilogram per meter, kilogram per second square. And now, to know the number of quantity that surface tension will contain. Now, acceleration is still derived. We need to reduce it. Then we can now see that meter, acceleration is velocity over time taken. So, V over TL. Again, there is still another derived quantity here. If you consider them one by one, mass is fundamental, time is fundamental, length is fundamental, but only the velocity is derived. So we need to reduce it just to know the number of quantity that surface tension will take. So this one will now give us mass, velocity is displacement over time taken, multiplied by d over t again, and then multiplied by L. Don't forget, we've said velocity is displacement over time taken, and we have t already here. So we have md tt L. That is md over ttl. Now to count the number of quantities now, then it will now give us 1, 2, 3, 4, 5. So it will make 5 quantities that surface tension will contain. And if you check the unit also from here, we are going to see that we are going to arrive at this kilogram per second square. Let's look at it together. Kilogram per second square. This one, kilogram, meter, second square, meter again, meter will cancel meter. Therefore, we are going to have kilogram per second square. Now, from this point now, you can now say that kilogram is unit from fundamental. Second is unit from fundamental. But if you look at the first unit of surface tension, Newton per meter, Newton is not from fundamental. So if the question asks you now, you should write the unit of surface tension from basic level. Then the number 2 unit will be the unit of surface tension from basic level, that is kilogram per second square. Why is it that this one is not from basic level? Newton is not from fundamental level. Out of the fundamental quantities and their unit that we have mentioned, Newton is not there. Why? Newton is for force, and force is not fundamental. That is why we cannot take this one as the basic unit of surface tension, but rather kilogram per second square, because kilogram is for mass, second is for time, and all those 2 quantities are from fundamental quantities. Take one more example, and the next example is work. Work, the formula for work is force multiplied by distance. Force multiplied by distance. Let's now see the various units that we can have for work. The first unit is the common one that we know, which is joule. Joule. That's the first unit of work. Now, to have another unit, let's come back to this formula. First is Newton. Distance is meter. So the number 2 unit now can be Newton meter. Now, if we express this formula further, so that we will be able to know the number of quantity that work can take. First, as I said the other time, is mass multiplied by acceleration, then multiplied by distance. Here again, if we express this one further, because acceleration is derived, so we can now have mv over t multiplied by d, because don't forget, acceleration is velocity over time taken. Again, velocity is still derived. Let's express further, then we can now have m d over t. Now, from this point now, you can now see that mass is fundamental, d, either distance or displacement, fundamental. Time, fundamental. So from here now, we can now count the number of quantity that work can take. That is 1, 2, 3, 4, 5. So this one we have 5 quantities now. Now, from this point again, we can now have another unit for work. Let's look at it together. Mass is kilogram. Distance, displacement, meter, that will be meter square. Time, that's second square. So it means the next unit of work will now be kilogram meter square per second square. Kilogram meter square per second square. Now, from this series of units that we have for work, you can now see that the basic unit of work is kilogram meter square per second square. The number 1 unit cannot be the basic unit because joule is not from fundamental unit. Number 2 unit also cannot be the basic unit because Newton is not from fundamental unit. But the only unit, series of units that we can have from fundamental unit are kilogram, meter, and second. And all this one present in work, which is in number 3 unit. So the basic unit of work is kilogram, meter square per second square. And the number of units, the number of quantity that work contain, we consider that is 5 quantities. Now, from what we've done so far now, serious question can be asked, especially under this work now. The first question is that all the following are units of work, except you can now see that work have more than 2 units, minimum of 3. They will now give you these 3 and give you another wrong one. You should be able to know that the 3 units of work are joule, Newton meter, kilogram meter square per second square. So these are the 3 units of work. Then you need to take note of this. Then again, if the question asks you to write the basic unit of any derived quantity, to write the basic unit, it means the first thing you need to know the formula of that derived quantity. Once you know the formula, analyze that formula like this until you get to its fundamental level. When you get to the fundamental level, as in the case of this work, then you should be able to write the unit that can be related to fundamental unit. That particular unit that is related to fundamental unit is the basic unit of that derived quantity. And this is convenient point to stop for today. For more lessons, please don't forget to subscribe. And if you have any question, as I said, you can ask your question from the comment section and from the WhatsApp link under the channel. Thank you.